When we evaluate expressions using the order of operations, we ensure that we start with the innermost grouping symbol. After we accomplish the innermost grouping symbol and figure out its value, we work our way from the inside out, following the normal steps. In this expression, we're going to look to this innermost grouping symbol right here, where we have the 2 minus 7 on the inside. After calculating 2 minus 7 and getting negative 5, we still look to this inside grouping, to the inside of this grouping symbol, and then right next to that we see that multiplication. So we're still going to leave the 5 on the outside and the 4 at the beginning of the grouping symbol, and we're going to follow that with a negative 15. Still inside the grouping symbol, 4 plus negative 15 has a value of negative 11, and we end with a complete and totally finished value of 16. Remember to work inside out. In this symbol, we bring in a new group, in this example, we bring in a new grouping symbol, and that's the fraction bar. The fraction bar serves the same function as a parentheses or bracket, separating the numerator from the denominator. So while I'm able to calculate the inside of that first parentheses, I follow that up with calculating the numerator separately. Negative 1 to the third power times 6. Negative 1 to the third power is negative 1, so that entire numerator has a value of negative 6. The denominator, of course, is just 2. Moving into the second part of the question, negative 4 times 8, thanks to the 2 to the third power, and we'll leave behind that division for the last step. In this step, we have two separate multiplications and divisions going left to right. Here we get a negative 32. Here we get a negative 3 for a final result of negative 35. Remember, the fraction bar is a grouping symbol, just like the parentheses and the brackets. In this next example, we first need to make a substitution of m equals 2 and n equals 6 into the expression. The negative 4 and the 11 both stay. Simplifying this expression further, the numerator of this fraction has a value of 72. 2 times 6 times 6. The denominator is still negative 4, and this exponent expression has a value of 121. Fortunately, we're able to divide 72 by negative 4 as division happens before addition. That fraction has a value of negative 18, plus the 121 from the 11 squared gives us a total value of 103. In our last example, we have a suggestion on what to do when the expression doesn't work out the way we had hoped. In this case, similar to the last one, we'll do substitutions. We can get rid of that x on the bottom as well. The substitution doesn't just have to happen in the numerator, despite the fact that that one's going to happen first, or that calculation is going to happen first. 18 from 6 times 3, 27 from 3 times 9, followed by a 6 in the denominator. And we are left with the square root of negative 9 over 6. Later on in this course, we'll discuss how to take the square root of negative 9. Despite the fact that you might think that it's negative 3, remember that negative 3 times negative 3 is positive 9, not negative 9. Because that negative symbol is inside of the square root, that expression has no value. We aren't able to finish the calculation because part of the expression cannot be evaluated. In this case, it's a good reminder to stay alert for those substitutions that result in an expression that we cannot evaluate.